viewers, welcome back to my channel. In this video I am discussing some important groups. This is the second video in the group theory. This is the part 2 video of the group theory. I am already uploaded introduction of group theory. Okay, what is the groups, and some most important questions also discussed about groups. Okay, this is the second video. In this video I am discussing some important groups. Okay, the first group is the GLNR group and SLNR group. What is GLNR group? Means general linear group, and SL indicates special linear group. Okay, here this is the definition: SLNR and GLNR. Actually we write down like this also: GLN over field and SL over N over field F. Okay, here fields we take Q, R and complex. These are the fields, we know that. Okay, in generally I am taking in place of F I am taking R. Here I am taking field as R. Okay, GL and R is equal to the matrix N by N over R, and where such that determinant of A is not equal to 0, and SL and R is equal to the matrix N by N over field R. Okay, such that determinant of A is equal to 1. This is the definitions for special linear and general linear groups. Okay, here actually GLNR or SLNR forms a group with respect to ordinary multiplication. Okay, ordinary multiplication. Okay, suppose I am taking some few examples. Okay, these are the matrices. Okay, we have to identify which matrices is general linear and special linear. Okay, what is the property of general linear? If determinant of A is not equal to 0, what is the meaning of this? Okay, except 0 we get any value of R. Okay, except 0. Okay, we not get determinant value as 0. Okay, other than 0 we get any value. Okay, that is general linear. Okay, if you get determinant value is always 1, then we called that group is special linear. Okay, I hope you understand. Okay, suppose we take some example. What is the determinant of this? Minus 1. Minus 1 is not equal to 0. That means what? General linear. Yes, general linear. This is special linear? No, because we not get determinant value is 1. Okay, and what is the determinant of value of this? 0, minus 1 and 1, 0. What is the determinant value? 1 we get. Yes or no? That means what? This is general linear also and this is special linear also, because this is not equal to 0 for general linear, and special linear what? We get determinant value is 1. Okay, and what is the determinant of this matrix? This is also one determinant. Okay, that means what? This is both special linear as well as general linear. And what is the determinant of this? 0. That means this is not general linear as well as special linear also. What is the determinant of this? 5. Determinant of this value is 5. That means what? This is only general linear. This is not special linear. Okay, I hope you understand the concept of general linear and special linear, and how to identify the general linear and special linear. Okay, I hope you get the idea about it. Okay, we write down one note. Okay, what is the note? Here SL is always subset of GL. Okay, SL is subset of GL because why? This is the GL group, and SL, this is the SL group. suppose we get see this in general linear, we get one determinant value is 1, we get 2 we get, except 0 we get any value of r, but SL we only get determinant value is 1. Okay, this one is comes into general linear also. Okay, suppose we take any, suppose we take one example. Suppose I am taking GL as collection of balls, collection of balls, collection of balls. What is SL? Suppose I am taking SL as a collection of white balls, collection of white balls. Now tell me, here SL is subset of GL or GL is subset of SL? Obviously SL is subset of GL only, because collection of white balls comes into collection of balls also. Okay, collection of balls includes white balls, yellow balls, red balls, black balls, anything. Okay, that means what? SL, that means white balls also included in this collection of balls only. Okay, I hope you understand for this example. Okay, that means what is SL is always subset of GL only, and SL is a part of GL always. Okay, SL is a part of GL always. Okay, SL is part of GL always. Okay, I hope you understand now. Now we have to prove how this GL and SL is becomes groups. Okay, that is the big task to prove. Okay, now we have to prove GL n comma r and SL n comma r is a group. How to prove? Tell me. Anyone tell me how to prove it? Okay, what is the definition? General linear. Here collection of n by n matrices over field R. Here property what? Such that determinant is not equal to 0. That is the property of general linear. Okay, suppose I am taking any two 2 by 2 matrices. Suppose I am taking A, B, C. Suppose A1, A2, A3, A4 I am taking the matrix, and I am taking matrix B, B1, B2, C3, C4, B1, B2, B3, B4. I am taking another matrix B. Okay, the determinant of this matrix what? I am taking 1. Suppose that means what? This is not equal to 0. Okay, yes or no? And I am taking determinant of A is also determinant of B also not equal to 1, equal to 1, and this is also not equal to 0. Okay, we know that one of the note of the properties of determinant. Okay, if the determinant of AB is equal to determinant of A and determinant of B, we know that this is the one of the important property of determinants. Okay, that means what? Determinant of AB is equal to determinant of A into determinant B. That means what? What is the determinant of A? That is 1. What is determinant of B? That is also 1. That is not equal to 0. This is equal to 1. This is not equal to 0. Okay, that means what? This is satisfies the closure property. What is closure property says? Tell me. If you take any elements in the group G, that means what? We take operation A star B, that is again belongs to group only. Okay, that means what? This is satisfies or not? Group property. What is here? Group is here property is determinant of A is not equal to 0. This is the property. Okay, we using the properties of determinant, we have to prove closure property. Okay, this satisfies the closure property, and we know that we also know that star is always a satisfies associative property also, we know that. Okay, we know that multiplication, ordinary multiplication is satisfies the associative property always. Okay, and we know that third property, that is what, identity property. Okay, suppose I am taking a matrix A, B, C, D. This is the matrix. What is the identity of this in generally in matrix multiplication, ordinary matrix multiplication? What is the identity? We know that 1 0 0 1. Okay, this is, we know that. Yes or no? We know that. Yes. Okay, that means what? We know that property of identity, what? A star is equal to A. This is the property which satisfies. That means what? A, B, C, D. I am taking the matrix with ordinary multiplication with identity 1 0 0 1. Suppose this is the identity. We multiply, we get again the same element only. A 0 0, B, C, D. This satisfies identity property also. And what is the inverse property? We have to prove last property, that is inverse property. How to prove this? This group is have a inverse. Okay, we know that in the matrices, what we know? Tell me, what is, how to prove, how to find the inverse? If the determinant, if A is invertible matrix, matlab what? Determinant of A is not equal to 0. This is the we know that invertible matrix. Okay, suppose A is the invertible matrix, then A inverse is equal to what? Adjoint of A by determinant of A. We know that this. Okay, the here what is the matrix? A, B, C, D here matrix. What is the A inverse here? What is the A inverse here? We get A, B, C, D. Okay, that means what here? Here adjoint what? We have to exchange these elements. We get the adjoint of 2 by 2. Okay, we get D, A here, and we take the negative sign to these two elements. Okay, that means what? Minus B minus C. This, and what is the determinant? We get AD minus BC. Okay, this is the inverse, we get A inverse. Okay, suppose this is the inverse element of the given matrix. Okay, that means what? The property of inverse property, what? Tell me. A star, A inverse is equal to E. We get identity. Okay, here what is A? Here A is what? Here A, B, C, D. And what is inverse element we taken? AD minus BC. Okay, here AD, that means D minus B minus C. D we get, A we get. Okay, we have to multiply this AD minus BC. Okay, what we get here? AD, we get AD and minus BC, and we multiply this minus AB and plus BA, and here we get CD and minus DC, and we get multiply this minus BC and plus AD. Okay, we get like this. Okay, we divide with AD minus BC. Inside we multiply 1 by AD minus B. What we get here? AD minus BC, we get cancels, we get 1, and AD minus here minus AB plus BA becomes 0, and CD minus DC becomes 0, and AD minus BC. Here minus BC plus AD is there, both are get cancelled, we get 1. We get identity again, we get identity or not, 1 0 0 1. That means what? Inverse property also these groups are satisfied. I am taking determinant of A is equal to 1. That means what? Here this is not equal to 0. Okay, this is both general linear as well as special linear groups also. Okay, like this we solve the we have to prove these both groups are, we proved these both are forms a groups with respect to what? Ordinary multiplication, ordinary matrix multiplication. These both are forms a group with respect to ordinary matrix multiplication. Okay, I hope you get the concept about general linear and special linear groups. Okay, now we go through some important concept. Okay, this is most important for competitive exams like IIT JAM, KSET, CSR Net Gate and other entrances also. Okay, this is important. Okay, order of SL and GL groups. Okay, now we have to find the order of SL and GL group. This is the most important important for exams. Okay, exam purpose this is important. Suppose I am taking one example. A is equal to 4 6 10 3. This is belongs to GL 2 comma here Z5. What here? Multiplication modulo 5 here. Okay, here GL is ordinary multiplication, here modulo 5. Okay, Z5. Okay, mod 5. This means what? Mod 5. Okay, how to solve this? Tell me. Z5 means what? The collection of 0 1 2 3 4. These are the elements in Z5. Okay, and 4 is belongs to this Z5. Yes, here 2 indicates what? 2 by 2 matrix. Okay, order of the matrix. Okay, and Z5 is the collection of these elements, and 4 is belongs to this collection. Yes, 6 is belongs to this collection. No, this 6 is not belongs to 4. Okay, here we divide, we have to this taken 5 6. Okay, 5 is a 5. Here we get what? We get remainder, that is the answer. Okay, here 1 is the remainder, and for 10, what is 10? 0 we get, because to divide 5 and 10, what we get? 5 2 is 10, we get 0, remainder 0, that's why 0. 3 is belongs to this case, and this is our required answer. Okay, like this we taken. Okay, and suppose I am taking one more example. Here GL. In general I am taking Z2. Okay, in general GL to Z2, what is the meaning of this? The matrix A B C D 2 by 2 matrix, the 2 by 2 matrix such that the determinant what? AD minus BC. Here not equal to 0, and the elements A B C D all are belongs to Z2 only. Okay, this is the meaning of ZL 2 comma Z2. Okay, this is the meaning of this. Okay, group. Okay, now we have to write down some important note. Order of SL and GL over ZP. Here P is prime. Here P is prime. The order of ZL over N ZP. Order, cardinality. Okay, both are same. Okay, What is the meaning of this symbol? This indicates cardinality. That means the number of elements present in that set, the given set. Okay, suppose we take in 1, 2, 3. What is the, suppose A, this is a set. What is the cardinality of this set? We indicate this. This is not a determinant, this is indicates cardinality. Okay, this is equal to what? 3. Okay, number of elements present in this set, that indicates the cardinality, or we call in groups, we call as that as order of the group. Okay, number of the elements present in the group, that is the order of the group. Okay, what is the order here? P power of n minus 1, p power of n minus p power of n minus p square, and so on, p power of n minus p power of n minus 1. Okay, how to remember this formula? This is important. We have to remember this because this is most important. Because okay, how to remember? First of all, we write down pn and reduce one term. Okay, what we get? Phi is phi naught, p power of 0. That means what? 1 only. Okay, into p power of n, and again we reduce. We increase 1 by 1. We take elements 1 by 1. We increase the p value. Okay, p power of n minus, we increase the again one more piece. We get phi square. Like this, we p power of n minus p power of n minus 1 we get. Okay, we get the values like this. Okay, and what is the order of SLN group? This is equal to, okay, p power of n minus 1, p power of n minus p power of, what is the as it is there in general linear. We write down first p power of n minus p square, and so on, p power of n minus p power of n minus 1, and we divide with p minus 1. Okay, this is the order of SLN over ZP. Okay, this is the concept of order of the SL and GL over ZB. Okay, now we have to see some examples asked in various examinations. Okay, we have to discussing. Okay, this is the question, first question. This is the question asked in NBHM 2008. Okay, let G be the group of invertible 2 by 2 matrix with entries from Z to, what is order of G? Okay, what is the given in this question? Let G be the group of invertible 2 by 2 matrix. Invertible means what? Here determinant is not equal to 0. Okay, invertible means what? Determinant is not equal to 0, and that matrix is 2 by 2 matrix. Okay, and with entries from Z2. That means what here? GL over order 2 by 2 and over Z2. This is the group. Okay, that determinant is not equal to 0 is given. That invertible means what? Determinant is not equal to 0. That means what? GLN over 2 by 2 matrix with Z2. Okay, we have to find the determinant of this order of the, sorry, not a determinant, order of this group. Okay, I am already given formula. What is the formula? P power of n minus 1, p power of n minus p. Okay, and so on, p power of n minus p power of n minus 1. Here n is what? Here 2. N is 2 here. Okay, n is 2. That means what? P square minus 1, p square minus, here what is p? 2. Here p value is 2. ZP. Here p value is 2. That means 2 square minus 1, 2 square minus 2, and we write down again. We write it again. Suppose I am taking next value 2 square minus 2 square minus 2 square, we get again, we get 0. That's why we stop here only. Okay, what we get? 4 minus 1 and 2 to the 4 minus 2 2, that means what here 3 we get into 2, that means what 6. J is the group of 6 elements. The answer is 6. J is a group of 6 elements. Okay, next question is find the number of 2 by 2 invertible matrix with entries from ZP. Here P is prime. Okay, that means what? Okay, this is the same question, both are same question, but here what they given? Here they given p value is 2 they given, but here in general they given, okay, here GL over 2 over ZB. Okay, that means what? The order is p square minus 1, p square minus p only. Okay, this is the answer. Okay, next question is what is the number of non-singular? Non-singular is what? Determinant is not equal to 0 and 3 by 3 matrix over Z2. That means what? GL what is order? 3 Z2. What we have to find the order? What we get here? 2 cube minus 1, 2 cube minus 2, 2 cube minus 2 square. This is we get, we solve this, we get 7 into 6 into 4, we get 168 is the answer. Then which option is correct? Option A is the correct option. Okay, next question is the order of the group G is equal to A, B, C, D, and what is the it given? Determinant of this matrix is what? 1. Okay, that means what? Here we take SLN group. Okay, this shows what we take. Here we take GLN or SLN, but in particular group we take SLN only. Okay, if you get determinant is equal to 1, we take SLN group. Okay, this is indicates SLN group. Okay, the order of SLN group what? ZP. Okay, p power of n minus 1, p power of n minus p. Okay, and so on, p power of n minus p power of n minus 1 by p minus 1. This is the formula, we know that, and we substitute here SL over what is the order is given. Order is 2 by 2, and what is here? Z3. Here p value is 3 and n value is 2, that means 3 square minus 1, 3 square minus 3 by 3 minus 1. We solve this. What we get? 9 minus 1 8, 9 minus 3 6 by 2, that means what we get here? 24. Then option C is the correct option. Okay, then last question, let P be the prime. This is the question asked in DU MSc 2014, and this question asked in NET, CSR NET. Okay, this is the question asked in NBHM 2010. Okay, these are the questions asked in various examination already. Okay, this is the question asked in JAM 2013. JAM 2013. Okay, let P be prime, let G be the group of all 2 by 2 matrices over ZP with determinant 1. Then what is the order of G? Okay, here what they given here? Determinant is equal to 1. We have to observe the what is the exactly question, what exactly question says. Okay, first of all we write down the what is the in the question what the given. Okay, we write down the key points given in the question. Okay, then after the we have to analyze what we apply for that question. Okay, first what they give here, P is prime. Okay, let G be the group of all 2 by 2 matrices. That means what? Here 2 by 2 matrix over ZP with determinant 1. Determinant 1 means what? Here SLN group. Okay, here write down here SLN group. Okay, that means here order is 2 and ZP over ZP is given. You have to find the order. Okay, p square minus 1, p square minus p by p minus 1. This is the, we know that. Okay, but in the options we have no this type. Okay, that means what, we again solve this. Okay, for the p square minus 1, how to write this? P plus 1 and p minus 1 and p square minus p by, and we get p minus 1. P minus 1, p minus 1 get cancelled, we get p plus 1, and we take p in this, we take p common, we get p minus 1 and p, we get like this. Then which option is correct? Option A is the correct option. P minus 1, p plus 1 and p. Option A is the correct option. Okay, these are the related to concept of SLN group and GLN group. Okay, I hope you like the video. If you like the video, please share to your friends, and also subscribe my channel, and like the video also. And what is the if you have any doubt regarding this concept SLN and GLN group, please comment in the comment box. Okay, thanks for watching. Thank you.